Welcome guys, this is MJ with MBJ Knowledge. If you're new to our channel, make sure to subscribe and don't forget to hit the notification bell if you are new to our channel. If you're a returning subscriber, we say thank you so much for always supporting us. We'll keep on delivering the best. Okay, today we have a question under transformers, that is physics, and it reads, Figure 9.1 shows a simple transformer which can be used to light a bulb. The bulb is labeled. Okay, if we look at the transformer here, we have a simple setup. The left part here represents the primary coil and the right hand part here represents the secondary coil. And always the secondary coil, that is where the load is. That is the output. Okay, so the input is the primary coil. Looking at our data given, we have 24 volts on the secondary coil here. At the same time, we've been given the watts, which is power, 36 watts. Then on the primary coil, we have only been given 240 volts. Okay, continuing with our question. When the mains supply is switched on, the bulb is very bright. Okay, state one way in which the potential difference across the bulb can be decreased without changing the mains supply. Okay, so one way, remember the principle of a transformer. When you want to increase voltage in the secondary coil, what do? You increase the number of turns. Okay, so whether this side it's 40 volts, whether on the primary coil it's 40 volts which is coming in, as it is going out, when you increase the number of turns, you expect the 40 volts to be increased as well. Okay, then if you want to reduce the potential difference or the voltage on the secondary coil, you have to reduce the number of turns. So for you to be able to reduce or decrease this potential difference across the bulb, what you're going to do is just to reduce the number of turns in the secondary coil. It ends there. So our answer there is by reducing the number of turns in the secondary coil. Let's go to question B1. For the lamp operating at the correct brightness, calculate the current in the secondary coil. For us to calculate the current in the secondary coil, okay, looking at the information given, look at the secondary coil. We've been given 1, voltage, 2, we've been given power. So we are just going to go direct and use the formula for power to calculate the current here in the secondary coil. Okay, so power is equal to what? Voltage times current. Power we've been given. Now, in case you've been given power in kilowatts, make sure you convert your power to watts if you are using it here under the transformer. Okay, take note of that. So this time around power is okay, it is in watts, so we use it. The voltage is there, so we substitute. Power is equal to 36 equals to 24 times current in the secondary. So the current in the secondary we don't know, so we divide by 24 on both sides. Okay, well, this side we're going to have 24, 1. So current equals to 1.5 amps when you divide 36 by 24. This is the final answer for B1. We go to question 2. For the lamp operating at the correct brightness, calculate the current in the primary coil. Assume that the transformer is 100% efficient. Looking at the primary coil here, we have not been given power. Okay, we only have voltage, meaning it is not possible for us to use this formula we have used on A. So which formula are we going to use? We are going to use the formula for those ratios. Let us just correct our data and then you see the formula we're going to use. So on the data, we've been given voltage in the secondary coil as 24 volts. Current in the secondary coil, we just calculated, which is 1.5 amps. And then voltage in the primary coil, we have 240 volts. Then primary coil, we do not have current. So question mark. Looking at this information, so it means we are going to use the ratios of the voltage. So this is the ratio of voltage And then we're also going to use the ratio of the current. That's the formula we're going to use. So voltage in the secondary over voltage in the primary equal to current in the primary divided by current in the secondary. Let us substitute the data. So the first ratio, we have 24 volts in the secondary divided by 240 volts in the primary equal to current in the primary, it's a question mark, that's what we are finding. So current primary, then current secondary, we calculated 1.5. Later on, we cross multiply. So 240 multiplied by current primary, we're going to have 240 current primary. And then when we multiply 24 times 1.5, we're going to have 36. Here, we are going to divide, okay, by 240 on both sides. So 240, and we divide this side on the left, we are going to have 1 times the current primary, we still have current primary, okay. So 240 dividing into 36, what do we get? Correct. So current primary is 0.15 amps. That is the current in the primary coil. If you look at the difference here, where you have a smaller number in terms of voltage, you expect current to be high. Where you have a bigger number in terms of voltage, you expect current to be low. And that is what is happening. So that is a trick that you need to be remembering. In case you calculate, you find that where there is a bigger number of voltage, you find a higher number of current. Just know that you have not done something right somewhere. Okay. That is all for today. It has been MJ, and thank you so much for watching the video up to the end. Thank you for supporting the channel. Please don't forget to subscribe and like the video, share to as many people as you can so that it can help them. See you in the next video.